ahead, you'll see there was an update. Remember, we did an update. And then there was a delete. Remember, we deleted a bunch of rows. And then there was a merge statement. So this is a log which allows you to understand what happened to your data over these four different operations that we performed on the data. So let's go ahead and keep scrolling. So now we're going to say, give me the data as of version 0. And remember, if we think back to the last notebook, that's what I did when I was joining the data to the Cosmos DB data set. I said, hey, I want to join these two Cosmos DB data frames to a Delta data frame, which is version 0. And if you take a look at version 0 of the data, magically, we're back to 0, 1, 2, 3, 4. Now, again, if you're a relational database person, you're sat there going, yeah, what's the amazing thing that's going on here? Well, the amazing thing that's going on here is ACID for Parquet, the file format Parquet. And that's what Delta Lake is all about, which is the name of this particular format. So at that point in time, we're going to take a pause from the notebooks. And I'm going to switch over for the last thing to show you, which is I'm going to show you some of the storage information for all the files that we've been reading and writing, so you can get a little bit of a feel for it. So if you take a look at here, this is one of our 15 million file directories, except this particular one you'll see is using lots of small files. So this is where we had lots of partitions. This is the, I think, the 100,000 row one, the 100,000 partition one. So lots of small files. You'll see the file format here is Parquet, but it has Snappy in front of it. So Parquet file formats support multiple different compression techniques. Snappy is the default. gzip's also very popular. So if we go back up here and we go back up to small files, big files, and we go to large files, small count, yes, that does make sense. And we go in here, and see here's the 15 million row data set again, except this time instead of having 10,000, we have way less than that. We have 10, and these files are much bigger. And you'll see here that even though we asked to write one file, we actually end up with multiple files because these map to the different partitions that we were looking at earlier on. And so there's a direct correlation here between number of files and the content of the files and the information that we saw. Right, final part of showing you information. Remember, we did 4 parts partitioning, where we used 4 different columns from the data set to partition. And we saw some pretty horrible performance because I was being silly and using 4 columns when just 1 or 2 would have done. And you can see here the name of the directory is actually the partition clause. And this allows us to be very efficient about navigating partitions and eliminating data. So here you can see for year 2002, we drill in here. You see there was only 1 month of data in there, so we can drill into month. There was only 1 type of payment in that 1 month, and there was only 1 vendor in that month. You get the idea, and so that's the file, and it's 4.5K. We go back up again, and we go to a more up-to-date data. We'll say year 2019. We have data for a whole bunch of months in here. Let's pick June, and you can see we have all 4 payment types. This is cash, credit card, etc. We'll pick one. I don't remember what one is, and there's 3 different vendors we used. So you can see that your choices don't just impact memory and performance in memory, they actually impact the structure and the layout on disk. And that's part of the reason why all of this optimization is done. All right, we're at the end of our time here. I have barely touched on Spark. For those who hadn't worked it out, I could easily have spent several more days covering some of this content and going through it with you. Performance optimization is one of the most important parts of Spark, and it's also one of the broadest parts of Spark. It is something that you should really learn about. There's lots of good books and good websites and YouTube videos to help you do that. We'll continue to produce more and more content at Microsoft because we use Spark very, very heavily internally as part of some of the exabytes that we process on our internal data lakes. And so we'll take some of that learning and move it forwards. So I hope you enjoyed the content. I hope that you are a little educated about some of the product experience that we have here for Synapse, but also some of the low-level interesting parts.